Good evening, class and professor. My name is Rich Shreve, and this is my final project for the network design proposal. The objective of this proposal is to replace the existing wireless network with a new standardized wireless network infrastructure that adheres to the 802.11 standards. The new network will enable construction workers to enter progress reports, provide Wi-Fi connectivity in modular homes, support wireless IP phones for sales employees, facilitate internet access for sales kiosks. We will be discussing the objectives of the network, intended users, design assumptions, equipment needs and proposed budget, network needs analysis, QoS requirements, reliability requirements, security requirements, list of equipment, and cost analysis. The main objective of this network is to provide a secure service that ensures the confidentiality, integrity, and availability of data, issue and incorporate robust security measures to protect sensitive information from unauthorized users, breaches, and other security threats. To get the current network up to date, the following actions need to be taken. Replace the wireless network with an industry standard 802.11 based wireless network. Upgrade or replace existing network equipment such as routers, switches, and access points to ensure compatibility with the new wireless network. Regularly apply firmware and software updates to network devices to address security vulnerabilities and incorporate new features. The network needs to support a variety of devices and applications, including iPad for construction workers to enter progress reports into the system, wireless IP phones for sales employees to communicate with customers, laptops for sales employees to access customer reports and printing capabilities, sales kiosks that connect to the internet and interact with a corporate office database. The network will facilitate collaboration with other offices and users in different locations by enabling secure communications between the corporate office and 32 sites through the internet or dedicated network connections. Support video conferencing, file sharing, and real-time collaboration tools to facilitate remote collaboration and communication. The network should be designed with scalability in mind to adapt to future changes, such as accommodating additional sites or expanding the existing sites without significant network reconfiguration, supporting increased network traffic as the company grows and adds more employees, customers, and devices, allowing for the seamless integration of new technologies, devices, and applications as they become available. The network should cater to the following mobility, client devices, and signal coverage requirements. The network should provide seamless and reliable wireless connectivity to mobile devices, such as construction workers' iPads, sales employees' laptops, and wireless IP phones, allowing users to move freely within the coverage areas without losing connection. The network should be compatible with the various client devices, including iPads, laptops, wireless IP phones, and sales kiosks. The network should provide significant signal coverage in each of the 32 sites to ensure reliable wireless connectivity in modular homes, sales office, and construction areas. Next, we will be going over design assumptions for unknown factors. Wireless interference, including factors such as neighboring wireless networks, physical obstacles, radio frequency interference, or other environmental conditions that may affect signal propagation. Network capacity requirements considers that the projected network usage falls within reasonable usage limits based on industry standards, and the expected usage patterns of construction workers, sales employees, and customers. Unforeseen expenses or changes in equipment prices may significantly impact the project's feasibility. It is assumed that the migration from the current wireless network to the new network will occur with minimum disruption to ongoing business operations and customer services. This considers that appropriate planning, testing, and implementation strategies will be in place to ensure a smooth transition, avoiding prolonged downtime or service interruption. Equipment needs and proposed budget. Wireless access points. Rough estimate for the number of wireless access points needed across the 32 sites is approximately 2 per site, depending on the site size and desired coverage. Recommended industry standard 802.11ac or AX wireless access points. Estimated cost for each wireless access point can vary depending on the model and features, ranging from 150 to 500 per unit. An approximate budget for wireless access points across 32 sites can be around 4,800 to 16,000. Network switches and routers will be required to support the wired infrastructure and connect the wireless access points to the corporate office network. The models and quantities will depend on the existing infrastructure and the desired network architect. Recommended gigabit Ethernet switches with significant port density for powering the wireless access points. The cost of the network switches and routers can vary based on the required features and performance. As a rough estimate, the budget allocated for the switches and routers can range from 10,000 to 20,000, depending on the complexity and scalability of the network. Wireless IP phones will be required for the sales employees at each site to facilitate communication with customers. Recommended industry standard wireless IP phones compatible with the wireless network infrastructure. The price per wireless IP phone can vary depending on the model and features, ranging from 100 to 300. Assuming 2 phones per site, the budget for the wireless IP phones can be around 6,400 to 9,600. Additional network equipment such as network cables, PoE switches, power backup systems, and network security appliances may be required to support the network infrastructure. The quantities and specific models will depend on the site requirements and network design. The budget for other network equipment can vary significantly based on the specific needs and requirements. A rough estimate for these components can range from 5,000 to 15,000, depending on the complexity and scale of the network. The network will serve various types of data, including data entered by construction workers using iPads to update the status of different community building sites, information collected from sales kiosks, including options selected by customers for their new home build, which will be entered into a database, reports generated by sales employees using laptops based on customers' choices, which will be printed for construction workers. The data collection from different sources will be used as follows. Construction workers will enter real-time progress updates on iPads to track construction activities, and this data will be sent to the corporate office for monitoring and project management purposes. The sales kiosk will collect customers' preferences and options chosen from their new homes. The data will be transmitted securely to the central database to update customer profiles and provide sales teams with access to customers' preferences for follow-up interactions. Sales employees will utilize laptops to compile and print customer reports, consolidating the selected options to provide comprehensive records for construction workers to use during the build process. The network will need to support multiple users at each of the 32 sites, including multiple construction workers per site using iPads for progress reports, 2 sales employees per site using laptops for customer reports and wireless IP phone communications, customers visiting the sales kiosk for browsing and choosing options for their new home. Speed requirements should provide reliable and fast connectivity to support their tasks efficiently, enable smooth and seamless data transmission for progress reports, customer inquiries, and data retrieval from the central database. A typical throughput expectation could range from at least 50 megabytes to 100 megabytes. Industry standard wireless protocol like 802.11ac or AX should be used to meet these speed expectations. The network load is likely to vary based on different factors such as time of day. Load may peak during business hours when construction workers are providing progress reports and customers are visiting sales kiosks. Customer traffic load could increase during peak customer visitation times. Data uploads Load may spike when multiple construction workers simultaneously upload progress reports, and sales data processing. Load could increase when sales employees generate and print their customer reports. Quality of service requirements. Implementing QoS policies to prioritize voice traffic from IP wireless phones over other types of data. Voice data packets will be marked with higher priority levels to ensure low latency and minimum jitter during calls. Reserve a dedicated portion of the network bandwidth for IP wireless phones to ensure significant resources for real-time voice communication. This will prevent call quality degradation during periods of network congestion. Implement call administration control mechanisms to manage the number of active calls and avoid overloading the network with voice traffic. If the network is close to its capacity, new calls will be denied until significant bandwidth becomes available. Implement redundancy and failover mechanisms to ensure continued IP wireless phone service, even in the event of network link failures or equipment issues. Device accessing applications. Traffic considerations. Apply QoS policies to classify traffic based on the type of application access. Critical applications such as the database access for sales teams will be given higher priority. Implement traffic shaping to control the flow of data and prevent excessive bandwidth utilization by non-critical applications. This will ensure that the essential applications have significant bandwidth for optimal performance. Regularly monitor application performance to identify any degradation in response times or application specific issues. This will help addressing performance bottlenecks and optimizing QoS settings for specific applications. Importance of devices connecting to application databases. Devices connecting to application databases, such as laptops used by sales teams, are critical for real-time access to customers' data and options chosen by customers. This allows the sales team to provide personalized service, make informed decisions, and close sales efficiently. Losing the connection to the database can result in significant operational disruption, including delayed customer interaction. Sales team members may not have access to the latest customer data, leading to delayed response and potential loss of customers' trust. Inaccurate reports. Progress reports generated for construction workers may not reflect the most up-to-date information, affecting project management and decision-making. Sales delay. Losing the connection to the database during customer interaction of sales kiosks can lead to delays in processing orders and negatively impact the customer satisfaction. Method to determine QoS for each application. QoS settings for each application will be based on specific requirements. The following factors will be considered. Real-time applications like IP wireless phones and video conferencing will be given higher priority than non-real-time applications like file downloads. Applications with bursty traffic patterns may require additional buffering or bandwidth allocated to maintain smooth performances. Applications that have highly sensitive to latency, such as voice and video, will be allocated significant bandwidth and given low latency QoS settings. QoS settings may vary based on the device type and its specific application usage. Different devices and applications may have varying QoS requirements to optimize performance and user experience. Users expect a highly reliable network that ensures seamless connectivity and minimum downtime. Reliability is crucial to support the various functions of the business, such as construction progress reports, sales integrations, and customer data management. Key reliability requirements include the network should have minimum downtime to ensure uninterrupted access to critical applications and data. Users expect consistent network performance to facilitate smooth communication and data exchange. Real-time communication, such as IP wireless phones and video conferencing, requires low latency for effective interaction. Implement redundancy mechanisms to ensure backup connectivity in case of network failures. The network should be capable of handling the load generated by multiple devices, including iPads, laptops, kiosks, and phones without degradation. Accordance with government requirements and industry standards, robust security measures need to be implemented to protect sensitive customer information and prevent unauthorized access. The nature of the business involves the handling of customers' data and financial transactions, necessitating strong security protocols. Key security requirements include encrypting sensitive customer data in transit and at rest to prevent unauthorized access and data breaches, implement role-based access control to restrict data access based on job roles and responsibilities, require strong user authentication methods such as multi-factor authentication for accessing sensitive systems and data, deploy firewalls and intrusion detection systems to monitor and prevent unauthorized access attempts, control regular security audits, conduct regular security audits, and ensure compliance with government regulations such as FCRA and FTC guidelines. Implement privacy measures to protect customer data, including obtaining necessary consent and maintaining data accuracy. Next is a list of projected equipment needed. We will need wireless access points, wireless IP phone, laptops, sales kiosks, and firewall, a VPN gateway, a Siri switch, a intrusion detection prevention system, and a router are all needed for the network. Finally is a cost analysis, which is broken down for each product needed. The tangible total cost is $108,680. Thank you for your time. Have a good day.